what the songs were for? Well, they weren't just for showmanship. It's about today's topic. In case you haven't noticed it yet, it's about music. Taking it straight out of the textbooks, Merriam-Webster defines music as the science or art of ordering tones or sounds in succession, in combination, and in temporal relationships to produce a composition having unity and continuity. On a more personal note, however, music is a way of expressing oneself. A happy day just isn't complete without a serving of bands like Panic at the Disco, Fall Out Boy, Paramore, and the like. Conversely, you never truly call yourself broken-hearted until you begin to understand the meaning behind the songs of, well, Coldplay. I could blabber on and on, but let's get down to brass tacks. At this point, you're probably wondering, why the heck is this dude discussing music in, of all subjects, math? Well, there's more to math than meets the eye, or in this case, ears. What we're gonna tackle today is the relation of music and the golden ratio.
I've learned so much.
You cannot talk about the golden ratio without mentioning the Fibonacci sequence. Now, as we delve into nature's details, one thing refuses to remain unnoticed. This is the order, the pattern, the symmetry that is behind all of it. You can see it in the smallest of flowers, the most obscure of leaves, and even the plainest starfish. We are enveloped in such an intelligent design, what most scholars of today are branding God's fingerprint upon nature. In fact, there are specific numbers that quantify what this fingerprint is actually made up of. Collectively, they are the Fibonacci sequence, and it goes a little something like this: 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. You may notice that in this pattern, the first and second add up to the third, and the second and the third add up to the fourth, and the fourth and the fifth add up to the sixth, and so on. This sequence was first discovered by mathematicians of India around 1,300 years ago, but it was made popular in the West by a man known as Leonardo of Pisa, aka the badass Fibonacci. Now, you may be wondering, nasaan na yung golden ratio dito? Fibonacci sequence pinag-uusapan eh. Di naman the topic to ah. Chill. The answer lies in the ratio between the Fibonacci numbers showing up. For example, try dividing any large Fibonacci number, let's say 144, by the number before it, in this case 89. What you will get for every succeeding similar pair is the same number. More specifically, it's 1.618. Conversely speaking, when we divide a Fibonacci number to the Fibonacci number it follows, we get a constant value, which is approximately 0.618, which is represented by a small phi. The Greeks discovered this long before the Fibonacci sequence, and they called it phi, not to be mistaken with pi or pi. It's phi. Today, however, it is more known to us by the name golden ratio. The Greek sculptor Phidias used phi to convey physical perfection in his sculptures, and we, the scholars of Math 1, are now going to use it to define musical perfection. Scholars of music and mathematicians observed patterns in some classical musicians' works. These said patterns somehow resemble the golden ratio, but nobody has proved whether they based their compositions on the golden ratio or if it was purely coincidence. Exhibit A, Wolfgang Mozart. Mathematician John F. Putz investigated whether or not the golden ratio occurred in Mozart's Sonata No. 1 in C major. The exposition consisted of 38 measures, and the recapitulation and development had 62 measures. In the first movement, Putz wrote, A 100 measure movement could not be divided any closer to the golden section than 38 and 62. It's a big but, however, that we cannot conclude that Mozart based his composition solely on mathematical principles because his third movement deviated from the golden ratio.